In this video, we will see another example for converting NFA into DFA using subset construction method. The language contains all the strings in which the third symbol from right hand side is A. So basic DFA for that would be as shown here. That last symbol could be A or B, second last could be A or B, but third last must be A. And before that, we can read any other symbol A or B. So there is a self loop on state A. So we can read any symbol, but to go to the final state, we have to read a DA. And after that, we have to read any two symbols, either A or B. So always the third last symbol will be A. And the transition table is also shown here. In step 1, we will start with the initial state and we will generate the successors of the initial state. So we have to find out the delta transition for both the input alphabets A and B. And whenever we have a new state, we have to generate successors of that as well. And as it is an NFA, there could be either a single state or there could be a multiple states as an output. So those states we have to combine into a DFA. So on input transition, on input A, the transition from A goes to state A as well as B. So this AB is the new state. And on input B, it remains on A, and A is already processed in step 1, so we don't have to process it again. In step 2, we will generate the successor of newly generated state A comma B. So A comma B gives state ABC on input alphabet A, and on input B, it gives output A comma C. So ABC and AC both are newly generated states. So we have to again generate the successors of that. Now note down that order of generation of successor is not important. You can first process AC and then ABC, or you can first process ABC and then AC. Doesn't make any difference in final DFA. But the provided you have to process or you have to generate successor of all the newly generated states. That's it. Order doesn't matter. So now we will generate the successor of AC states. On reading A, we are going to state ABD from state A, and on reading input B from A, we are moving to AD. Now ABD and AD are again a new state. ABC is yet to process from step 2. So we have 3 states which are yet not processed. Again, we can choose anyone in random order. So let's process AD state. So when we read A from AD, it goes on A or B states. AB we have already processed in step 2. And on reading B from AD, it moves to state A, and A is also processed in step 1. It means there will be only arc updation. No new state is added. Just arcs will be added on input A and B from AD. Still, we have 2 unprocessed states. So one of them is ABC. When we read A from ABC, that will lead to 4 states A, B, C, and D. Again, it is a new state, so highlighted in red color. And on reading B from ABC, we are moving to ACD. So ACD is also yet not processed. It's a new, and hence it is highlighted in red color. Next, we will process state ABD, which was generated in step 3. Okay, yet it is to be processed. So on reading A from ABD, we are moving to ABCD, which is already generated in step 5, yet to be processed. And on reading B from ABD, it generates ACD. ACD is also already generated in step 5, but it is yet to be processed. So now we have 2 states, ABCD and ACD, which are yet not explored. So now we will explore both of them. So first we are generating successor of state ACD, and it leads us to state ABD, which is already generated and explored. And on reading B from ACD states, it leads us to AD. Again, AD is already processed and it's already generated, so no need to process either AD or ABD. And the last state we have to explore was ABCD. So on reading A from all 4 states and taking the union of their outputs, individual transitions, it leads to ABCD, that is, it will remain on same state. And on reading B, it goes to ACD. So now we do not have any new states. All states are explored. So whenever there is no new states are generated, simply arcs will be updated from current state. Okay. And this would be the final DFA. Now it contains 8 states. And if we draw the DFA for this, it will be very complicated. So it is not necessary that you have to draw, always you have to draw transition diagram. The transition table also represents the same information. So that is fine if we compute only transition table. Right? Because with 8 states that will be very, very complicated to draw on paper. But this represents the same thing. So this is the final DFA of given NFA. NFA has just 4 states, whereas this DFA is having 8 states. If you observe, as there are 4 states in NFA, its power set would have 2 power 4, that is 16 states. Right? But we are not generating power set that we have learned from previous videos, because power set will will generate unnecessary states. Many will be non-reachable from the initial state and we don't need to process them. And that is why we are using the subset construction method. So all the states would be definitely reachable from the initial state. So instead of 16, now it would generate only 8 state, and that will also give the correct DFA. So this is our final answer. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.